Molar concentration.
In chemistry, the molar concentration is defined as the amount of a constituent divided by the volume of the mixture. It is also called molarity, amount of substance concentration, amount concentration, substance concentration, or simply concentration. The volume in the definition refers to the volume of the solution, not the volume of the solvent. 1 liter of a solution usually contains either slightly more or slightly less than 1 liter of solvent because the process of dissolution causes volume of liquid to increase or decrease. The reciprocal quantity represents the dilution volume, which can appear in Ostwald's law of dilution.
Notation.
In addition to the notation, there is a notation using brackets and the formula of a compound like. This notation is encountered especially in equilibrium constants and reaction quotients.
Units.
The SI unit is mole per meter 3. However, more commonly the unit mole per liter is used. A solution of concentration 1 mole per liter is also denoted as 1 molar, 1 m. An SI prefix is often used to denote concentrations. Commonly used units are listed in the table hereafter.
Related quantities. Number concentration.
The conversion to number concentration is given by. Where is the Avogadro constant? Approximately 6.022 x 1023 mol. 1.
Mass concentration.
The conversion to mass concentration is given by. Where is the molar mass of constituent?
Mole fraction.
The conversion to mole fraction is given by. Where is the average molar mass of the solution, is the density of the solution, and J is the index of other solutes. A simpler relation can be obtained by considering the total molar concentration, namely the sum of molar concentrations of all the components of the mixture.
Mass fraction.
The conversion to mass fraction is given by.
Molality.
The conversion to molality, for binary mixtures, is where the solute is assigned a subscript 2. For solutions with more than one solute, the conversion is.
Properties. Sum of molar concentrations, normalizing relation.
The sum of molar concentrations gives the total molar concentration, namely the density of the mixture divided by the molar mass of the mixture, or by another name the reciprocal of the molar volume of the mixture. In an ionic solution, ionic strength is proportional to the sum of molar concentration of salts.
Sum of products molar concentrations, partial molar volumes.
The sum of products between these quantities equals 1.
Dependence on volume.
Molar concentration depends on the variation of the volume of the solution due mainly to thermal expansion. On small intervals of temperature the dependence is. Where is the molar concentration at a reference temperature, is the thermal expansion coefficient of the mixture.
Spatial variation and diffusion.
Molar and mass concentration have different values in space where diffusion happens.
Examples.
Example 1, consider 11.6 g of NaCl dissolved in 100 g of water. The final mass concentration, NaCl, will be. The density of such a solution is 1.07 grams per milliliter, thus its volume will be. The molar concentration of NaCl in the solution is therefore. Here, 58 grams per mole is the molar mass of NaCl. Example 2. Another typical task in chemistry is the preparation of 100 milliliters, equals 0.1 L, of a 2 moles per liter solution of NaCl in water. The mass of salt needed is. To create the solution, 11.6 g NaCl are placed in a volumetric flask, dissolved in some water, then followed by the addition of more water until the total volume reaches 100 milliliters. Example 3. The density of water is approximately 1000 grams per liter and its molar mass is 18.02 grams per mole, or 1 over 18.02 equals 0.055 mole per gram. Therefore, the molar concentration of water is. Likewise, the concentration of solid hydrogen, molar mass equals 2.02 grams per mole, is. The concentration of pure osmium tetroxide, molar mass equals 254.23 grams per mole, is. Example 4, a typical protein in bacteria, such as E. coli, may have about 60 copies, and the volume of a bacterium is about L. Thus, the number concentration is. The molar concentration is. If the concentration refers to original chemical formula in solution, the molar concentration is sometimes called formal concentration. For example, if a sodium carbonate solution has a formal concentration of, now 2CO3, equals 1 mole per liter, the molar concentrations are, now plus equals 2 moles per liter and, CO32 equals 1 mole per liter because the salt dissociates into these ions.